Well, thank you for joining me in this nugget called Configuring the LAN here in DCUCI. My name is Anthony Sequeira, and what we're going to do is quite straightforward here. Now that you understand conceptually LAN traffic in your UCS system based on our earlier nugget dealing with the B-Series LAN infrastructure, we're now going to teach you everything you need to know about configuration. We're going to configure those VLANs. We're going to configure private VLANs, uplinks. I'll show you how to bundle uplinks into a port channel. We'll even look at creating those fiber channel over Ethernet storage ports and see how we can create those fiber channel over Ethernet VLANs. Very important here in this nugget that we do all this correctly because we're trying to get application data traffic, right, from our UCS system into the upstream 7K environment and beyond. Now, the first thing that we're going to do here is actually review. I did show this when we were talking about our LAN infrastructure in the UCS conceptually in our earlier nugget, but let's just review it real quick. In order to create a VLAN, what are we going to do? We're going to go to the LAN tab in the UCS manager. We are going to go to our VLANs node under the LAN cloud. We can see we've got this split screen here, don't we? And we can see our VLANs in this top pane. Notice there is a plus button, and we're going to bring up the Create VLAN wizard. You're going to give your VLAN a name, like, oh, maybe you've got them kind of geographically organized, so sales. And notice that there are two required fields here, the name and the VLAN ID. What's really interesting about this is the name is what we're going to use in a virtual NIC policy. That's right, the name is so important here, not necessarily the ID. Both are required, but the name is really the important part because why we use the name under the virtual NIC configuration is so that we can abstract that from the VLAN ID. We could actually change the VLAN that goes with sales, and that would not create a big problem for us in the UCS system. So really give your names consideration. They're going to be used under virtual network interface configs. Remember that we can configure the VLAN only on Fabric A, only on Fabric B, or common. And the common global configuration, of course, is the most common. Both fabrics configured differently, of course, would allow us to configure the same name but different VLAN IDs on the different fabrics. Again, very rare that we would do that. So there's our required fields for the VLAN creation, name and ID. Remember, we have the check overlap button, and sure enough, 101, the VLAN ID I chose here, does indeed overlap with the test VLAN that we created in that earlier nugget. So that's a great feature. I'll indicate that this is VLAN 102. I'll say OK, and it says successfully created VLAN sales 102. The traffic on this VLAN will flow on all uplink ports which are not part of any network group. Interesting. So we're seeing what I talked about earlier with you, and that is the fact that by default, all of your VLANs are permitted on those uplink ports northbound in the UCS system. We can create network groups in order to restrict this, but by default, all VLANs flow up all uplinks. We'll say OK, and we just successfully reviewed VLAN creation in the UCS system. Now, by the way, verifying the VLANs you created, as you see, is quite simple because we have this VLANs node. Here we can see the sales one that we just created, the test VLAN one we created in the earlier nugget, and of course, VLAN 1, which we cannot we cannot delete. That's the default VLAN. But what about VLANs that you might create for test purposes that only exist on a Fabric interconnect? Let's have some fun with that. So I've got the VLANs node selected. I'm going to go over to plus, and I'm going to say, let's say Fabric B underscore test as the name of the VLAN. This is only going to exist on Fabric Interconnect B, and I'll number it 200. I'll say OK, and that gets created. Now, look, you're a little off balance because nothing happened in your VLAN area. Yeah, it's seemingly that particular VLAN did not get created. But it did. It's just that it only exists on Fabric B. So sure enough, under the LAN cloud node here, they do have Fabric B. And we can expand Fabric B. We can take a look at its VLANs. And there we see the Fabric-specific VLAN that we created of Fabric B underscore test. Now, it's probably at this point you realize that VLAN creation in the UCS system is something that you would want to get paid by the hour for. I mean, think about it. What if you need to create 80 VLANs? You're going to have to do quite a bit of clicking and data entry in the UCS system. But fortunately, with the UCS Manager version 1.3 or higher, there's a better way. And this is important because remember, we can't use VLAN trunking protocol to dynamically learn our VLANs in the UCS system. So watch what we can do. We're going to go back under the VLANs for the entire LAN cloud. There we go. And I'm going to go back to my add button and notice what it says in the wizard here. It's a VLAN name or prefix. So I could say something like R and D underscore VLANs. And that's going to be a prefix for the VLAN IDs 210 through 280. So we are going to create a bunch of VLANs here dynamically, automatically, if you will, all of those different VLANs 210 through 280, and they'll have the prefix R&D underscore VLANs, and then they'll get the VLAN ID as part of their name. We'll check for an overlap, always a good idea, especially when creating a range like this. We'll say OK, and notice we have created a whole bunch of VLANs very efficiently in one fell swoop. Now, in our earlier nugget, I alluded to in VLAN creation the fact that we could do private VLANs in the UCS infrastructure. And we certainly can, but with a little bit of a limitation compared to private VLANs as you might know them. So let's go ahead and consider some VLANs here for ports. So let's say these are all representing ports that we have in what we're going to now call a primary VLAN. And this is the terminology that the UCS uses. So we have this primary VLAN. We just created a whole bunch of VLANs together. Those all could have been considered primary VLANs. Now, what we can do is we can take ports in this primary VLAN and we can create what's called an isolated VLAN. You can consider it a sub-VLAN if you like. And these isolated ports are only going to be able to communicate with a single port in the infrastructure that is called a promiscuous port. Promiscuous is always hard for me to spell. Promiscuous. There we go. I passed my spelling quiz. As you know, I'm a terrible speller without spell check. So anyways, we got it right. So the promiscuous port, think Madonna in the early 90s. The promiscuous port gives these isolated VLAN ports the ability to communicate with the rest of the world. By the way, obviously this promiscuous port is going to be one of your uplink ports, right? So interesting, we have these isolated VLAN ports that can only communicate with the promiscuous port. They can't communicate with each other. They can't communicate with other primary VLAN ports. It's a very, very strict security mechanism that you can put in place in the UCS system. Now, the rules in the UCS system for this are very, very strict. You can have one and only one isolated VLAN per your primary VLAN. Now, if you're used to the private VLAN concept in the classic iOS environment, you know that there is also something called a community sub-VLAN. And the community sub VLAN, the ports inside it can all communicate with each other. So this is an added benefit. This concept does not exist in the UCS. So we have our primary VLAN. We have for that primary VLAN the potential to create one isolated VLAN, and that is it. Now, if you want more information on the private VLAN feature that's available for us in Classic iOS, all you got to do is head up to CBT Nuggets at YouTube and just search there on private VLAN. You'll find several excellent micro nuggets free of charge, which are going to completely review this classic private VLAN structure for you. Obviously, we also have courses that deal with it, like our Switch course, and I suppose that's where you might want to head to, since if you're watching this video, you're a subscriber to CBT Nuggets. But it was worth plugging our amazing YouTube channel, where there are plenty of great free training options in the form of micro nuggets. Okay, so that's the private VLAN structure as it exists in the UCS system. Let me just remind you where this would be configured in the interface. So here we are back in the graphical user interface, and it would be very easy to create these VLAN structures. Watch this. You would go and create a new VLAN wizard, create a new VLAN with the wizard, and give it a name like primary underscore VLAN. And then what you would do once you give it a VLAN ID is you would come under here and mark it as primary. You would go ahead and create it. And then when you're creating your isolated VLAN within that one, you would just mark it as isolated and you would specify from the drop down the primary VLAN. So they make it very, very easy for you to create the primary VLAN and its one isolated VLAN below it. So awesome. We have the VLANs and we are masters of their creation in the UCS system. Here's our Fabric Interconnect A. Here's our Fabric Interconnect B. We're in a primary subordinate type environment between these two devices. As you know, we can now create VLANs, ranges of VLANs, a private VLAN structure with the isolated sub VLAN, and we've really mastered that aspect of the LAN configuration. But wait a minute. In a real environment, we are going to be making connections to LAN equipment upstream. We pretend in this course that we have an unlimited budget, and if we have an unlimited budget, we're going to have some beautiful 7000 series devices upstream, of course, and we are going to want to make uplink connections to these LAN devices. Where do we configure uplinks? We haven't seen that, I don't believe, in any previous nugget. It is absolutely simple. Let me show you how you would do that in the GUI. So to configure the uplinks, we just have to think, where are the uplinks? Well, the uplinks are from the Fabric Interconnect northbound to the LAN, right? The northbound LAN. It's obviously not shown in our equipment. We don't have any Nexus 7Ks here, but if they were here, we're thinking about, okay, those uplinks to those particular devices. So where you would go to configure an uplink is your Fabric Interconnects. Let's go ahead and expand them. We'll select Fabric Interconnect A. We know we have our fixed module and our expansion module. You can go to your Ethernet ports. Notice there is a filter up here pre-built for you. I'll uncheck all, and all of the Ethernet ports on the fixed module disappear. And I could say unconfigured, for instance, to see what are my unconfigured ports. The first unconfigured port is port ID of 5. So what you could do is you could expand your Ethernet ports. You could go to port number 5, and you would see it highlighted on the physical display, and we would go reconfigure, and we could go ahead and configure that as an uplink port. It says, are you sure? We say yes, and bang. It's that easy to configure an uplink port. By the way, if you choose unconfigure, you do this, obviously unconfiguring of what you just did. You can disable the port from here. You can choose show interface from here. And please know for your exam that this is where we would manipulate the flow control policy as well as set the speed of the particular interface and give an optional user label. We can see faults easily associated with this particular object as well. So the creation of our uplinks is very, very simple thanks to the configure option that we have. I'll choose unconfigure and we'll set port 5 back to an unconfigured state. Now, as I record this, my birthday's coming up. And you know what I'd love for my birthday? I'd love a t-shirt that says, I love port channels. Yeah, what we could do here for our uplinks is we could add physical links and we could bundle them together. This is great from a high availability perspective, a load balancing perspective. It's just great, period. Now remember, in order to have this magic happen on the upstream devices, on the northbound devices, you want to configure LACP and get them to actively be attempting to form a port channel with the other side. What do we do in the Fabric Interconnect? Well, I'm glad you asked. I'm going to show you. So yes, you're going to be very impressed with how easy this is. Ready? Let's go to port 5 and let's configure it as an uplink. Awesome. And then we'll do the same on port 6. Excellent. So we have ports 5 and 6 that are uplink ports. Imagine they're connected to our shiny new Nexus 7K northbound up there in the local area network. Now we're interested in creating our port channel. Let's go over to the LAN and look at this. Under our Fabric Interconnect, we have the ability to do a port channel. And guess what? There's a beautiful port channel wizard that walks you through this and makes it simple. We'll use port channel ID 1. We'll go ahead and give our port channel a name, my first port channel. And it says, uh-oh, you violated the syntax rules. How about my underscore first underscore port underscore channel? Oh, and now we have too many characters. How about my underscore first underscore port underscore cha? All right, there we go. And then we choose next. What's the next step of this wizard? Well, it's to add ports. So we say, okay, ports 5 and ports 6, we are adding to this port channel. We choose finish, and it says you just successfully created your port channel. Verification is simple. We can see the port channel appears now under the port channel node for our Fabric Interconnect A. Awesome stuff. Now, if we go in under this port channel and double click it, notice we get information such as properties. The administrative speed would be under properties, very important. And here we can disable the port channel and add ports to the port channel. How would you delete a structure you create like this, by the way? Well, you would disable it, and then we'd go over and we'd right-click that port channel and choose delete from the interface. So the creation, verification, and deletion of port channels, very simple thanks to the UCSM. That's the Unified Computing System Manager. Now, remember on the Fabric Interconnects, we have what we called server ports. These server ports lead down to the input-output module on the chassis. So I'll just say IOM right here. We remember this is inside our chassis. Guess what? Remember, you recall this, I'm sure, from the video where we covered this, but remember on second generation equipment, like if we have a 6248 Fabric Interconnect and we have a 2208 input-output module, we can create port channels out of these links. It is a very inflexible load balancing scheme that will be utilized on these server ports. Remember this, it is source, destination, MAC address, load balancing, and that is it. But obviously this is a tremendous benefit to us. The server blade traffic is going to be pinned to the virtual port channel interface, and this is awesome. This has a lot of great benefits for us from a high availability perspective. So This is possible, port channels here. This is indeed reliant on the type of hardware we are using in the UCS system. And let's jump in the GUI so I can remind you of where this is configured. In order to do this, we go to our Equipment tab. We select the main equipment node, and then we go over to Policies, and we're interested in our global policies. Remember this? You've seen it before in a previous nugget. The port channel is done automatically as long as your hardware supports it. So remember, on our chassis FEX discovery policy, we select our number of links, and we had a detailed discussion about this in an earlier nugget dealing with our fabric interconnects. And then we are going to say that, hey, we want a port channel. We want to bundle these links together. So it's an automatic process as part of the chassis/FEX discovery policy. Now, obviously, when something happens automagically like that, verification becomes absolutely critical. Where would you go to verify that automatic port channel creation? Well, think about it. It's the I/O module, right? So you could go ahead and expand your I/O module, go to your I/O module 1, if that's where we did this initially, and go under Fabric Ports. Here you can inspect your fabric ports, and this is where you would verify port channel membership. Specifically, notice that we have a port channel field here under the properties of the specific I/O module port that we are discussing. Now, when we were discussing our port personalities, one of the port personalities we mentioned we could have would be a fiber channel over Ethernet storage port. We would do this when we are connecting to an fiber channel over Ethernet storage device, like from EMC or from NetApp. Now, as you might guess, this configuration is going to be very simple for us in the graphical user interface, but there is a catch. In order to attach one of these devices directly to the fabric interconnect, we need to be in fiber channel switching mode. Yeah, we cannot be in the default NPV mode like we discussed in our overall SAN connection nugget a few moments ago. So, wow, we have two configurations that we would want to make. Let me show you where those are just to refresh you on that. So your first order of business when connecting a fiber channel over Ethernet storage device would be to go to your fabric interconnect and get it out of the default NPV mode. Remember how to do that? Select the fabric interconnect and you'd go to set fiber channel switching mode. Yeah, you'd put it into that mode so that you could then go and connect your storage device. Doing that would be a matter, of course, of selecting our port, going into reconfigure, and choosing configure as fiber channel over Ethernet storage port. So again, simple to do, but there is that catch you need to remember about resetting the default NPV mode. Now, what if we had a appliance, a storage appliance that speaks like iSCSI that we want to connect directly to the fabric interconnect? Well, guess what? No big special configuration here of the fabric interconnect itself. It can just natively do it. So let me go over to port 9, for instance. You would choose reconfigure, and you would choose configure as an appliance port. But there is one additional thing you would need to do here, and that is create what's called the internal VLAN for that storage appliance to actually function. And how you do that is by going over to your LAN tab and scrolling down, and notice there is the appliances cloud here. And under appliances, there's our VLAN option. So we would create our internal VLAN here under this appliances node in order to create that internal VLAN that would be utilized by the appliance and the appliance port that we configure. Well, you know what time it is. Here we are, nearly at the end of our nugget. Let's have some fun with final exam time, and no, don't panic. So in the exam environment, you might be faced with a simulation. Maybe like click in the correct area where you would configure an uplink port channel. Ah, interesting. And what is the load balancing method that's used? Well, let's go ahead and answer that straight away, shall we? Do you remember what is the only load balancing option that we have? It is indeed, let me grab my pen, source, destination. Remember, it's MAC. Not IP address, it's source destination MAC addressing that is used for the load balancing, and that's the only option, at least with the current software that we are working with. Who knows what Cisco will invent in the future? In fact, I would be willing to wager that in the future we'll see various algorithms able to be set. Now let's jump into the interface and ask this question or answer the question about where we go to configure that uplink port channel. So in our exam environment, they drop us off, let's say, theoretically, hypothetically, they drop us off right here at the main equipment node inside the Unified Computing System Manager. Where do we configure our port channels for uplinks? Well, you remember that as far as the uplinks themselves go, we can go in and take a look at ports on the appropriate fabric interconnect. And we can easily use the reconfigure button in order to create uplink ports. Once we've created our uplink ports, we go over to the LAN tab. And remember, for each of your fabric interconnects, you're going to have a port channel option here, and we have an add button for the port channel that launches the Unified Computing System Manager wizard for the creation of port channels. So this seems really super easy for us, and that's because we just covered it. Please keep in mind that the Unified Computing System Manager has a wealth of nodes that you can click on, tabs that you can click through. This is a very extensive graphical user interface. So do spend some time practicing so you can find things quite easily. Another point I'd like to make is that that was the port channel that was going to the northbound local area network infrastructure. What about port channels that we want to make going to the servers themselves in the UCS chassis? This, of course, refers to bundling between our fabric interconnect and our input-output module. Remember, that had to do with the particular policy. Remember that global discovery policy on the fabric interconnect itself. In fact, to get there, we went all the way back to equipment. We went to policies, and under global policies, we had the ability to port channel the links that go from the chassis to the fabric interconnect. So a little bonus review there of what we looked at in this particular nugget. Speaking of this particular nugget, I sure hope it has been informative for you, and I'd like to thank you for viewing.